All right, IED. This is going to be a activity 2.3.2, evaluating materials, the Martian habitat. So we have spent a little bit of time in class talking about different types of materials and how to choose different types of materials based on their parameters and their material properties. So you would start off with listing out parameters that you find desirable for your material, and then you would search those properties from those parameters, because in real life there's thousands upon thousands of materials, whereas if you were to just think of these off the top of your head, you could only come up with maybe, I don't know, 15, maybe 20 materials, and then after that, your brain's just out, and you're like, I can't think of anything else. There are online databases that have like thousands of materials that have been made by people, so you've got to be able to know how to select those, and we're going to do an exercise in that. So this is a make-believe exercise. So we're going to design a habitat that is built on Mars. And since it is actually built on Mars, that means that the construction materials are going to be completely different. So we have a Martian material list instead of a regular material list, and none of these materials are actually real things. But the point is to try to look at the different properties and find out how those different properties actually make a difference to us. So if we look at the Mars schematic, if you just click on the link at the top from the assignment, it's going to give you this page. So the Mars habitat diagram gives you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 components. So like a radiation shield, a thermal insulation layer, an internal shell, a solar panel, electrical cable, foundation, communications cable, and all of these are going to have to be made of different materials. So you can kind of take the guesses and see, because it gives you some hints. It says, like, the solar panel must convert solar energy to electrical energy. The electrical cable must conduct electricity from the solar panel. So it's giving you hints at what these properties should look like. And what you're going to do is you're going to take the engineering materials chart for either the PDF student version or the Excel student version, depending on which one you want to use. The PDF is easier because it just loads up straight in Canvas, and the Excel one may or may not load up quite like we would want it to on a Chromebook. So if you click on this bottom one and it doesn't work out, try to go for the PDF student version and you'll be okay. All right, so if we look at in this material list, it gives you several different properties that you can use, and all of the Martian ID names of these materials are going to have different properties that go along with them. So if you're trying to look for something by its density, you would use these numbers. If you're trying to look at something by its yield strength, it's going to be these numbers. If you're looking for tensile strength, it's going to be these numbers. Okay, you might have to go back and look up what these different definitions mean. This is higher up in activity 2.3.2, so it's in the same lesson. You just might have to go up and click on the links to the different material properties to see what each of these are. There was also a quiz on it, so if you uh, did that, you can go back and you can look up what those answers are from there, and that would actually work as well too. Just keep in mind though, a couple of things is that one yields. Hang on. Toughness is not hardness. So if it talks about toughness, that doesn't necessarily mean that it's going to necessarily be rigid or hard. And the hardness doesn't necessarily mean that it's tough either. So remember, the hardness is its ability to withstand bending, okay, and the toughness is the ability to withstand impacts. The electrical resistivity is something that they give us, and remember, resistivity is your ability to resist electricity. So if you're looking for something that's a good conductor of electricity, you're looking for really low numbers on that one. If you're looking for something that resists electricity, you're looking for really high numbers. And something, because we did this activity yesterday in class, so something that students had some issues with that I'll go ahead and point out. These are given in scientific notation, so 10 times 10 to the 12th power is a really big number, because every time you have an extra number in the exponent, you're going to add a 0 to that number. So 10 times 10 to the 12th is 10 with 12 zeros after it. So it's a really large number. Same thing with like 10 to the 15th. The bigger this exponent gets, the larger the number is. So some of these numbers are like absolutely huge. And then you've got other numbers like 15. Okay, well, in the grand scheme of things, from 10 to the 12th power to 15, 15 is a really low number. and students were having a little bit of trouble determining whether or not there was a conductor or an insulator. And they were like, well, but 170 is a big number. I was like, well, $170 may be a big number, but when it comes to resistivity, 100 to 170 is actually still a pretty good conductor of electricity. You're getting to bad territory when you start getting these like exponents involved, like 10 to the 8th or ninth or 12th or even like 21st. So like this one, lambda rate, if you try to pick that one to be a conductor, no bueno, it's not going to happen. So just keep that in mind that these properties have values from low to high, and they're given that way for a reason. And if you're having trouble finding specific properties, let's see if I can actually get this to scroll over. If you're having trouble finding specific properties, like whether or not it's corrosive, resistant or not, you can look over on the other end and there's some notes, and it gives you a brief description of the material, and it tells you what's used and what's not used, and what it might actually be used for, what it looks like. Okay, because like there's a couple of hints there. It's like, whenever it says glass transition temperature, there's a good possibility that that's going to be some type of clear material or some kind of glass material, and then so on and so on. Here's another one that says like crystal clear or translucent. So, it gives you some things that might not necessarily be given by just a number. So, like if you're trying to say if something's clear or not, how are you going to write that as a number? It's really hard to do. I'm sure somebody's done it before, but not my problem. All right, so what you're going to do is you're going to list out what each one of these parts are going to be made of, and then that's what you're going to submit to me, what each one of these parts are made of, with a justification. So, like, and it doesn't have to be a big justification. It just needs to be, why did you pick that one? What material property did you select? So, if you wanted to pick like the Jupitarp, that's the one that is reminiscent to me. If you wanted to pick Jupiter for something, I need you to like write it either like above or below the spot, or you could just like submit this on a Google Doc. That's fine too. And you just remember, just write out all the different names. So, what did you pick for the radiation shield? What did you pick for the thermal insulation layer? And then tell me why you picked it. And that's going to suffice for this assignment. So, I hope you guys have a great day, and I hope that made a little bit of sense. And if not, you can ask me questions, and we'll talk later.